Good morning, boys and girls. My name is Carol Stoops, Mrs. Stoops, and I'm also baby Henry's grandmother. And the theme of this week's Vacation Bible School is God's living water. And we know that God created the world and everything in it. And on day one, he created light. On day two, he put the sky in place. And on day three, God said, "Let the water under the sky be gathered to one place, and let dry ground appear." And God called the dry ground land, and the gathered waters he called seas. So we can see from this inflatable globe that where the land is, the dry ground on our planet. And we can also know where the geologists have kind of put these land masses into continents. So we have here where we are in just below Lake Michigan in North America, South America, Europe, Asia, Africa, Australia, and Antarctica. You can't really see the color of Antarctica, but it is white, and that's because the land mass in Antarctica is covered with over a mile of ice. Now, when we look at the globe of our planet, what color is the most prominent color that you see? Blue. That's right, because God made our planet so that 70% of our planet is water. And this water exists in three states. It's in the solid state, in ice, in the liquid state, in all the seas, the lakes, the rivers, the oceans, and it's in the air, in the atmosphere around our planet, as water vapor, as the water evaporates from the water and goes up into the clouds, gets saturated and falls back down to earth as water to replenish the water. So why do you think God put all of this water on this planet? Do you have any ideas why he did that? Why might you think he did that? He could, so that plants could have water, so that the animals could stay alive, so that we could live on this planet, because without water, there would be no life on this planet. So water was made to be life-giving for the people who live on this planet. And he gave water some very unique properties that we're going to talk about this week. Besides 70% of our planet's surface being water, our bodies are 70% water. And that water helps circulate all the nutrients, the oxygen, to every cell in our body. And it's without water, we need to drink. You probably need at least 4 glasses of water, probably between 2 and 3 bottles of water. And milk is 87% water, so that counts as hydration if you drink a lot of milk. And since God made this so much water and he made it to be life-giving, let's find out some about the science of water. And every day this week we're going to talk about one property of water how God made it to be uniquely for us and for our life. And the first thing we're going to talk about today is the density of water. Now, the density seems like it's complicated, but it's really how many water molecules are packed together in a certain volume. And we're going to talk about the density of water by comparing it to the density of some other objects that I have accumulated here on this tray. Some objects made of different things: styrofoam, wood, plastic, metal, and we're going to predict which ones sink and which ones float. Because if it sinks in water, then it is more dense than water. And if it floats in water, then it is less dense than water. So let's start with this key. What do you think will happen with the key? It's made out of metal. It sinks. What about this whisk that also is made of metal? Okay. Let's try a glass stirring rod. Do you think this will sink or float? It sinks. So it is also more dense than water, the metal and the glass. Let's try some plastic things here. Let's try this little plastic toy. Oh, it floats. Whether plastic floats or sinks depends on how dense actually the polymer is that they put in the plastic. Here's a boy, a little ring. Yes, that floats. That floats because just like a life ring will float, it has air in it, and the air is less dense than water. What about these little Hatchment toys? Let's try the little fish. Will it sink or will it float? Okay, it sank, so it is more dense than water. What about this rubber stopper? Okay, it's more dense than water. What about these birthday candles? Do you think they're made of wax? Will they sink or will they float? Well, they are floating, so they are less dense than water. What about these crayons that's also made of wax? Let's see what they do. They take a little time, but they end up sinking, so they are more dense than water. What about these styrofoam balls? They're basically air. Well, they are going to float because they are mostly air, and air is less dense than water. What about this buoy? It's actually a foam buoy. This is actually made for boaters who have keys. So it will float in the water. And here's one actually with the key on it, and it tends to float with the top up. What about these wooden sticks? Wood as a rule is lighter, less dense than water, and it will float until it gets saturated with water. I have here a coffee pot. I actually don't know what this will do, so let's see. I'm thinking it will float, and it does because it has air in it, so it's going to be lighter and less dense than water. So we know that everything floating on top here, the styrofoam ball, the candles, the wood, the little boat key, and the life buoy, they are less dense than water because they're not falling down. There's also another property. This is actually called a buoy, a life buoy, B-U-O-Y, and that's named after a scientific concept called buoyancy. And buoyancy is actually the force of the water that keeps something afloat, and it is balanced by gravity. And gravity is directly related to weight of a thing. So you don't really know anything about buoyancy until you try to sink the object that's floating, and then you can feel, well, yeah, there is a force there that's keeping that from going down into the water. You may notice it more if you try to get on an inflatable raft in the pool. You just can't get those things to stay underwater, and it takes a fair amount of force to take them completely underwater. So that's what buoyancy is, the ability of an object to float. Okay, so we have determined that. Now we're going to move on to the second. I'm going to take some of these objects out here. let them dry. Get the whisk out because I need that. And we will come back to the water tank in a little bit. But the next thing we're going to talk about with density is that water itself can be more dense or less dense. And that happens because of temperature. And if you take hot water and layer it over cold water, we're going to see what happens, because as water heats up, the molecules of water start bouncing around and start getting excited, and they kind of break the bonds. And we're going to look at the structure of water tomorrow, but it becomes less dense as it gets warmer. And so we're going to see what happens if we try to layer cold water and hot water. So we're going to take, I have some hot water here, and we're going to put that in here. I want it to be about 113 degrees, so I'm going to probably have to put an ice cube or two in this. Let's see what it says here. It's 150. So let's put an ice cube in there and let that melt for a second. Then another property of water is that it takes a lot of energy to heat it up, and it takes a lot of energy to cool it down. But you may notice that, like if you put hot water in a bathtub, the bathtubs are insulated a little bit, but that bath stays hot for a long time. And that's good. That's one of the properties God gave us to help us. I'm going to put cold water in this jar, and I'm going to turn these around where you can see them a little better. And we're going to check the temperature of this. Okay, probably could use another part of an ice cube anyway. And you can see that ice floats in water, doesn't it? And why does ice float in water when it's just water? And that's because as you look at a snowflake, you can see that as water freezes, it changes its shape and the molecules of water move further apart. So it is less dense and it floats up to the surface. Okay, so that's about perfect. It's about 113, 114. So I'm going to take that ice water out, and we're going to make that cold, get that up to the top. And we're going to put some food coloring. We're going to put red food coloring in the hot water here. And you can see that because the water has more energy and it's more exciting, that red water takes up, that red dye spreads out into the water pretty quickly. And we put the blue in the cold water. It takes a little while for it to go into the water. If I can get this open here. It just kind of is sitting there on the water. So I have to stir that a little bit to get that to change color. Okay. So now we have the hot water in the red, the cold water in the blue. And we're going to put the hot water on top of the blue water. And in order to do that, I'm going to have to invert this. I'm going to do this with my other hand here. Okay. And we're going to slide that onto the top of the blue water, and then carefully take out this tray. And you can see that a little bit of it is mixing and turning purple. But most of it is staying layered. The hot water is staying on the top and the cold water is staying on the bottom. And that is because of the density of the two different phases of water. This is a good thing in the oceans and in the rivers, because as the sun heats up the top of the oceans, that water doesn't sink down into and mix with the cold water. It stays up in the section where, so that the food for the fish can live. And this will stay like this for like 24 hours at least before it will equilibrate. So now we're going to see what happens if we reverse that. If we put the hot water on the bottom and the cold water on the top. And we know that the cold water wants to sink. It is denser. So we'll see what happens. Put a little blue food coloring in this. Get that started to mix up a little bit. Get a put red in the hot water. Mix these up. Now we'll do the very same thing, except we'll reverse it. We'll put the hot water on the bottom and the cold water on the top. Try not to knock the other one over in the process. So we're going to move this all over here so it's right on top of the other one. And what happens? That cold water wants to go down and the hot water wants to come up. And so the colors immediately mix and we have purple. So that tells us that the density of water does make a difference and that it's important for life on our planet. Now there's one other thing that we're going to talk about today, and that is, why do fish change? How can they live if they go down into the depths of the ocean and then they come back up to the top? How do they do that? How can they change their density when they are in the water? And they can do that because God gave them a special air bladder. So we're going to demonstrate that here by calling this little bottle the fish's body. Now, fish is probably not this heavy, but we're going to call this the fish's body. And I have here a little balloon that I'm going to put inside the body of the fish. And we're going to pretend that this is the fish's air bladder so we can see what happens. We're going to put this all into water, make sure all the air bubbles are out of the bottle. And put the fish down in the bottom of that. Okay, now I'm going to inflate the fish bottle. See if you can put it over by this side. See if we can see it better. And I'm going to do what the fish does. We're going to add some some air to the bladder and see what happens. As we add air, the fish is going to be able to come up to the top and float. as we take out air, then the fish will sink down to the bottom again. I'm going to put this, see if I can turn this so it will stay on the front of this instead of coming back towards the back. There we go. Okay, so try it this way. And we'll do that again. We'll inflate the air bladder. And the fish comes up to the top. And then as they deflate it, they can adjust their depth in the water by using this little air bladder. So God did some amazing things when he created the oceans. He put all the wonderful fish in them, and he gave them the ability to go up and down in the water. And he changed the density of water so that the warm water will rise so that the fish can stay alive. So he thought things out so clearly so that there could be life on this planet. And we're very grateful to him for doing that. Tomorrow we'll learn about another property of water, and if we want to play around with this a little more, we can. Have a good day.